You're welcome to Organotope Chem Clinic. I am Temitope Adeniji. Today we'll be solving UITH nursing practice question that will enhance your score in the coming exam. And I will advise you to stay till the end for the tricks and tips that will help you to perform excellently in this exam. You're welcome back. Let's take the first question right here. Question number 1. If calcium has atomic number 20 and mass number 40, the constituents of atom is, so we have our option right here. This question is actually talking about the isotope of calcium. What is an isotope? An isotope is an atom of the same element with the same atomic number but different mass number, owing to the difference in their neutron number. And we need to understand that elements have their symbol representation. We call it chemical symbol of elements. It is written as this, A, Z, where A denotes the mass number of an element, also known as the atomic mass, and the atomic mass is the sum of the proton number and the neutron number in the nucleus of an atom, which implies that A equals proton number plus neutron number, okay, in order to determine the atomic mass. YZ denotes the proton number, which is the same thing as the atomic number of an element. E is the symbol representation for an element, so it can be hydrogen, helium, lithium, any element, okay? But right here, the element we are considering is calcium. We have element calcium, Ca. Now we're told in the question that the atomic number of calcium is 20. So right here you write the atomic number. While the mass number is 40. We have the mass number. Okay? So this calcium 40, 20. So we have to determine the proton number. The proton number is unknown. We need to determine the neutron number of this isotope of calcium, unknown, while the electron number is not given as well. So we have to determine 3 parameters right here: proton, neutron, and electron number. In order to determine the proton number is equal to what? The atomic number of an element. So the proton number is equal to what? 20. Proton number is equal to 20. Okay? Now we need to determine the neutron number. We make N, which is the neutron, the subject of the formula right here. Therefore, we have N equals, we take Z to the other side by rearranging. We have A minus what? Z. The value of A from this isotope is 40 minus, and the value of Z, which is the atomic number from this isotope, is 20. Therefore, we have 40 minus 20. The neutron number equals what? 20. So we have the neutron number right here. Okay? Then the number of electrons for this particular isotope. Note that for a neutral element, the atomic number is always equal to what? The electron number, provided it is a neutral element. In an instance whereby you are dealing with a charged atom, then the number of electrons is not equal to what? The atomic number, in the case of what? A charged atom. So therefore, we've been able to deduce that the electron number is as well equal to what? 20. So for this isotope of calcium, the proton number equals 20, neutron number equals 20, and the electron number equals 20. So the option to pick right here is Option B. Okay, B is the answer. We have 20 proton, 20 neutron, and 20 electron. Make sense? Moving on to the second question on the properties of metals. We have, which of the following is not true of metals? A. They are good conductor of heat and electricity. Metals are good conductor of heat, which implies that they have high thermal conductivity. Metals are good conductor of electricity. It implies that they contain mobile electrons. Option B. They are ductile and malleable. Metals are ductile. Ductility implies that they can be drawn into wire, while malleability implies that they can be hammered into sheets or pressed permanently without breaking. Option C. Their oxides are basic. Metal oxides react with an acid, resulting into formation of salt and water. Since their reaction results into formation of salt and water with an acid, therefore metal oxides are said to be what? Basic. Like for example, we have the reaction of magnesium oxide with hydrochloric acid. This results into the formation of what? Magnesium chloride and water. The magnesium oxide is basic. Why? This is an acid. Okay. Therefore, resulting to form what? A salt and water. So a substance that reacts with an acid to form salt and water is said to be basic. So metal oxides are basic. So option C is correct for a metal. Option D. They can be used as insulator. This is not true about metals because metals are known for the ability to conduct heat and electricity. But insulator resists the flow of heat and electricity. Example of insulators are rubber, ceramic, plastic, etc. All these do not conduct heat and electricity. Therefore, metal cannot be used as insulator. Make sense? So for question number 2, the right option, which of the following is not true of metals? They can be used as insulator is incorrect. So the right option is option D for question number 2. Moving on to the third question. Question number 3 is on cracking of petroleum. We have petrol can be obtained from fuel oil by A. Hydrolysis, B. Hydrogenation, C. Dehydration, D. Cracking. Option A. Hydrolysis is used to enhance the combustion of petrol. Okay, that is the rate at which petrol burns in excess supply of oxygen. While option B is hydrogenation. Hydrogenation is the process by which hydrogen is added to an unsaturated hydrocarbon in petroleum fraction, thereby increasing the carbon to hydrogen ratio in the compound. Dehydration of petroleum, also known as oil dehydration, is the process of removing water from crude oil or petroleum. Option D, we have cracking. The process by which petrol is obtained from fuel oil, that is the heavy fraction of crude oil, is known as cracking. And also, cracking is the breaking down of larger hydrocarbon molecule into smaller fragments by heating at a temperature of 400 to 600 degrees Celsius under pressure in the presence of a catalyst. We have various types of cracking process. We have the catalytic cracking, which involves the use of catalyst in the cracking process. We also have the thermal cracking, which involves the use of high heat in the cracking of alkane molecule. We have the hydrocracking, which involves the use of both heat and hydrogen in the cracking of hydrocarbon molecule. So back to the question, petrol can be obtained from fuel oil by which of the option? That's right, cracking. That is option D is correct. Make sense? Moving on to the next question. This question is on mole concept. That is the determination of number of molecule, number of particle, and number of ion. We have how many atoms are there in 0.3 moles of an element? Given that the Avogadro's constant Na is 6.0 times 10 raised to the power 23. We have our options right here. Recall that one mole of a substance is equivalent to 1 Avogadro's number. That is 6.023 times 10 raised to the power 23. But in this question, we're given the Avogadro's constant as 6.0 times 10 raised to the power 23. So we'll make use of the constant given to us in the question. Okay? Now recall that in order to determine the number of molecule, number of particle, number of ion, we need to multiply the Avogadro's constant with the number of mole of an atom. So number of mole times 6.023 times 10 raised to the power 23 will give us number of particle. In the case of radicals, we have what? Ions. Number of ions. Number of atom. Number of molecule. So anytime you are asked to find the number of particle, number of atom, number of molecule, you are expected to multiply the number of mole of that substance by the Avogadro's constant. So right here we have to determine the number of atoms. So how many atoms are in 0.3 moles of an element? Therefore, number of atom equals 0.3 times 6.0 times 10 raised to the power 23. Okay? So if you press your calculator, we are going to have 1.8 times 10 raised to the power 23. Okay? Atoms. So let's go back to our option. Option A, 2.0 times 10 raised to the power 24, incorrect. Option B, 1.8 times 10 raised to the power 28, incorrect. Option C, 1.8 times 10 raised to the power 23. This is the correct option. So option C is the right option for this question. Make sense? Now we are on question number 5. This question is an extract from mole concept as well. How many moles of oxygen atoms are present in 4.0 gram of the gas? Given that the atomic mass of oxygen is 16, we have our options right here. From mole concept, we can deduce that the number of mole of a substance equals reacting mass over molar mass. So here we are dealing with oxygen. So the reacting mass of oxygen atom over the molar mass of the oxygen atom. Note that we are dealing with oxygen atom, not oxygen molecule. Okay? So when you are talking about an atom of oxygen, the molar mass will be its what? Atomic mass, which is 16. But if the question is demanding that we determine the number of mole of oxygen molecule, that is when we multiply the 16 by 2 to have what? 32 for the oxygen molecule. So molar mass for oxygen molecule is 32, but the oxygen atom is 16. Therefore, the number of mole reacting mass from the question is 4.0 over the molar mass of oxygen atom is 16. Therefore, we have 4.0 over 16. What do we have from the calculator? That's right. We have 0.25 mole. Okay? So, how many moles of oxygen atom are present in 4.0 gram of the gas? We have our option to be what? Option A is correct. 0.25. Make sense? So at this point, we've taken 5 out of 10 questions. So if you are among the set of students that will be taking the UITH nursing entrance examination, kindly go through the playlist for more video lessons, which will serve as a guide for you to pass this coming examination. So if you find this video lesson so interesting, kindly subscribe to the channel, and you can also share and like this video lesson. Now moving on to question number 6. In the periodic table, all the elements within the same group have the same what? We need to understand that in the periodic table of elements, the vertical column is the group, while the horizontal row is the period. Now, the first option right here, we have same number of electrons. From the periodic table of elements, elements in the same group do not contain the same number of electrons. Now, let's take for instance, hydrogen is in the same group with lithium. The number of electrons of hydrogen is 1, while that of lithium is 3. So, which implies that elements in the same group do not have the same number of electrons. The same number of shell, option B. Elements in the same group has varying number of shells. Now, the first element right here, which is hydrogen, contains 1 shell. The elements in period 2, 2 shells. Elements in period 3, 3 shells. While that of period 4, 4 shells. So, elements in the same group do not have the same number of shells. Option C. Number of valence electrons. Elements in the same group do exhibit the same number of valence electrons. Hydrogen right here has 1 electron in its outermost shell. We have hydrogen, 1 electron in its outermost shell. The lithium contains 1 electron in its outermost shell as well. Okay, that's 3 electrons for lithium. This is for hydrogen, while this is for lithium. So, elements in the same group exhibit the same number of valence electrons. Option D says elements in the same group has the same number of neutrons. Neutron number is determined by subtracting the proton number from the atomic mass. So elements in the same group do not exhibit the same number of neutrons. So the right option is option C. So C is the answer for this question. Note that in the periodic table of elements, down the group, the shell number increases down the group as we move from hydrogen to lithium to sodium and potassium. While across the period from left to right, the shell number remains constant. But what happens? The number of electrons in the outermost shell tend to increase across the period. Like in lithium, we have 1 electron in the outermost shell. In beryllium, we have 2 electrons in the outermost shell. Boron 3, carbon 4, nitrogen 5, oxygen 6, then fluorine 7, and neon, which is a noble gas, 8. So the electron number in the outermost shell increases as we go from left to right across the period. Question number 7 is also an extract from hydrocarbons. Now, the benzene produces more soot than ethane on burning because we have our options right here. But let me talk about these 2 compounds right here. The benzene is a hydrocarbon, while ethane as well is a hydrocarbon. We have the benzene has alternating double, single, double bond in its cyclohexane structure. And we have ethane with 2 carbons saturated with hydrogens, hydrogen. The carbon to hydrogen ratio in benzene is higher than that of ethane. And at the same time, we need to understand that the double bond, alternating double, single, double bond, double, single, double bond in benzene is highly responsible for the high degree of unsaturation in benzene. Therefore, the degree of unsaturation in benzene is responsible for these soot. The soot flame is the black flame that comes out of benzene when it is undergoing combustion. So when you take a sample of benzene and you introduce it into a burning flame, it brings out a black flame as if you are burning a tire. So that is the soot that we are talking about. Why the ethane is saturated because it has single bond all through, no double bond like we have in the case of the benzene. In benzene we have 3 double bonds, which is responsible for higher degree of unsaturation. So the answer to this question is option A, higher degree of unsaturation. So the molar mass does not account for this soot flame. The liquid state does not account for the sooty flame, and also benzene do undergo other reaction other than addition reaction only. So this is wrong for a benzene. Make sense? Moving on to question number 8. This is an extract from empirical and molecular formula calculation. What is the molecular formula of a compound whose empirical formula is C5H7N and its molecular mass is 162? We have the atomic masses of the elements that make up the compound right there. And here are the option A to D. The relationship between molecular formula and empirical formula can be expressed as molecular formula equals empirical formula N. Okay? So also we can find N, which is always a whole number, by finding the ratio of molecular mass and the empirical mass. Okay, molecular mass over empirical mass. From this question, we have the molecular mass as 162. N equals 162. Can we determine the empirical mass from the empirical formula? Empirical formula is given as C5H7N. Okay, let's determine the empirical mass. We have 5 carbon atoms there. That is 12 times 5 plus 1 times 7 for hydrogen plus 14 times 1 for nitrogen. So we have 60 plus 7 plus 14, which is equivalent to what? 81. So the empirical mass is 81. So we divide this with what? 81. N equals 2. So in order to find the molecular formula, we need to multiply the empirical formula by 2. We have molecular formula equals, what is our empirical formula? C5H7N. When you multiply by 2, molecular formula for this particular compound becomes what? C10H14N2. Okay, now we check our options. Not option A, not B, not option C. So the correct answer is option D. Question number 9 is an extract from organic chemistry, that is the homologous series of organic compound. Now the homologous series is the family of organic compound in which each successive members differs from the next by a CH2 group or relative molecular mass unit of 14. You can check my video lessons from the playlist on homologous series for better understanding. From question number 9, we have C2H4 belong to the same homologous series as which of the compound in this option? We can deduce that the compound C2H4 belong to which homologous series? Let's find the simplest ratio. When we divide 2 and 4 by 2, we have 1:2, which implies that the compound here has the empirical formula CH2. Multiply the empirical formula right here by N. We have the expression CnH2n, which is the general formula for the alkenes. We have the alkenes general formula right here. So from the options, we can see that the number of carbon is 6 in each of the compound right in the option. So N equals what? Yes, N equals 6. So can we insert N into the general formula here? We have C6H2 times 6, 12. Okay, so the answer to this question is C6H12. Which option? That is option A. Makes sense? Interestingly, we've gotten to the last question, which is question number 10. So I want to believe that following the questions from 1 to number 10 right here, we've been able to understand the kind of questions that we should be expecting for the UITH entrance examination on chemistry. So I will advise you to go through the playlist for other chemistry topics on physical chemistry, general chemistry, inorganic chemistry, and the organic chemistry. And do not joke with your organic chemistry. So let's take this question right here. What is the pH of a solution that contains 0.05 molar? Molar is the same thing as mole per dm cube. Aqueous solution of sodium hydroxide. So the concentration of the sodium hydroxide is 0.05 molar. So we have to find the pH. Okay, in an instance whereby you are given a base, just like the sodium hydroxide, which is a base, okay, that shows that before you can get the pH, you have to determine what? The pOH. Is that taken? Because the concentration given right here is for the base and not for an acid. So recall that pH plus pOH equals what? That's right, 14. Okay, so we need to find the pOH first, since we are dealing with a base right here. pOH equals negative log to base 10 of what? Hydroxide ion concentration. Okay, so we have the hydroxide ion concentration right here. So we have pOH equals negative log to base 10 of what? 0.005. Okay, so pOH equals minus what? Log 0.005 will give us minus 2.3. Okay, so when we find this, minus negative times negative will give us what? Positive. Therefore, pOH equals 2.3. Okay, so in order to find the pH, the question has actually requested for pH. We need to subtract 2.3. We subtract the 2.3 from 14. We have pH equals 14 minus 2.3. What do we have? pH equals 11.7. Okay, so the pH of this solution is 11.7, while the pOH is 2.3. Okay, so when you are starting with an acid, you determine pH and you end up with pOH for the base. From this question, we've been able to determine the pH of the solution. So option A, we have 2.3 incorrect, B 4.7 incorrect, option C is correct, 11.7. So the pH of the solution is 11.7. Make sense? Easy peasy. Boom. If you've answered the questions 1 to 10 independently, kindly drop your score in the comment section. I'll be there to respond accordingly. So if you find this video lesson interesting and helpful, kindly support us by subscribing, sharing, and liking our channel and videos. Thank you so much for watching, and I wish you the very best in your upcoming entrance examination.